Section 8.7 is on solving quadratic equations of the form ax squared plus bx plus c equals 0. So this is a little different from the previous section because while we still have a quadratic equation that starts with an x squared and has a bx and a c, in this case a is going to be a number greater than 1. So a could be something like 2 or 3 or 5. To do this, we're going to basically use factoring by grouping. The first thing we're going to do is look for two numbers whose product is a times c. So two numbers that multiply to whatever a times c is. And then those same two numbers need to have a sum of b. So what two numbers multiply to a times c and add up to b? We're going to use these two numbers to rewrite b, to rewrite our coefficient of x. That's going to give us 4 terms, and then we're going to factor by grouping. This is a little tedious to do, and it's a lot of steps, but it always works. So let's take a look at some examples here. So let's factor the polynomial 5x squared plus 13x plus 6. So I'm going to look for two numbers that multiply to whatever a times c is. So a is 5, c is 6. So I need two numbers that multiply to 30. And then the same two numbers have to add up to b. So they have to add up to 13. So there's a lot of different factor pairs of 30. So I could do 1 and 30, 2 and 15, 3 and 10, 5 and 6, and then I would start to repeat again. Now, do any of those make me think of 13? Actually, there's two possibilities here. If I subtract, I can do 15 minus 2 gives me a 13. But notice, I don't have any subtraction here. Neither of these are negative numbers. So I'm going to have to go with 3 and 10. Because 3 times 10 is 30. 3 plus 10 is 13. Now, those two numbers, the 3 and the 10, I'm going to use those two numbers to rewrite 13. So I'm going to say 5x squared plus 3x plus 10x plus 6. Okay? Notice, I didn't change my problem. I just broke up 13x into 3x plus 10x. And where did I get the 3 and 10 from? Those were the two numbers that worked over here. Now I'm going to do my factoring by grouping like we did a couple sections ago. Group the first two and then group the last two. Take a greatest common factor out of each set of parentheses. So in this case, the only thing I can take out is an x. And that's going to leave me with a 5x plus 3. Out of here, I can take out a 2. And that's going to leave me with a 5x plus 3. And notice that I have a 5x plus 3 in the parentheses that's repeated. So one factor is going to be 5x plus 3. And my other factor is x plus 2. And that's my final answer. That's the factored form of my original polynomial. Now, this is a little more complicated than we did in the previous section where once we found these two numbers, we just kind of threw them into the parentheses with x's. You can't do that here. If you have a number in front of x squared, if there's not a 1 there, if there's a number other than 1, then you have to go through these multiple steps. Let's take a look at another example. Here I have 6x squared plus 22x minus 8. Well, the first thing that jumps out at me with this problem is that all of those coefficients have a common factor of 2. So the first thing I'm going to do is factor a 2 out of each of those. So 3x squared plus 11x minus 4. This does a couple things. It actually, you will have to, if you're going to factor it completely, you do have to take out any greatest common factors. It's also going to give me some smaller numbers to work with here. So now I'm going to be, and in fact, what I usually do is I will usually circle this 2 because I do not want to forget that. That has to be a part of my final answer. So now I'm going to take a look at my trinomial here, and I'm going to look for two numbers that multiply to a negative 12. And I got that negative 12 because 3 times negative 4 is negative 12. And then the same two numbers have to add up to 11. Now, I know one of these is going to have to be negative because when I multiply two numbers to get a negative, one of them has to be negative. So I'm thinking probably 1 and 12. And in order to make my second equation true, the 1 is going to have to be negative. So negative 1 times positive 12 is negative 12. Negative 1 plus 12 gives me a positive 11. So I'm going to use those two numbers to rewrite my 11x in the middle. So I'll have 3x squared minus 1x plus 12x minus 4. So I use this negative 1 and this 12 to rewrite 11x. So 11x is the same as negative 1x plus 12x. Now, I'll put parentheses around the first two, parentheses around the last two. Factor by grouping, look for a greatest common factor that I can take out of there. Well, let's see. So with the first one here, I think all I have that I can take out is an x, and that's going to leave me with a 3x minus 1. Out of the second set of parentheses, I can take out a 4, and that's going to leave me with a 3x minus 1. So, writing my repeated factor of 3x minus 1, and then my other factor is the other two terms put together. And I'm not done. I need to remember to put my 2 out front. This 2 comes down and goes out front. So my final answer, final factored form, is 2 times 3x minus 1 times x plus 4. And let's take a look at this last example here. I have 4x squared minus x plus 7. So I'm going to be looking for two numbers that multiply to 4 times 7, which is 28. And then the same two numbers have to add up to my coefficient of b, which is a negative 1. And right away, there's nothing jumping into my head. Two numbers that multiply to 28. So I'm going to make a list of factor pairs. So I have 1 and 28, 2 and 14, 3 doesn't go in, 4 does, 4 and 7, 5 doesn't go evenly into 28, neither does 6, and I'm back to 7. So 1 and 28, 2 and 14, 4 and 7, none of those I can add up, even if one of them or both of them is negative, to give me a negative 1. So there are no numbers that will work here, so this polynomial is actually prime. If you can't find numbers that will work, your polynomial is going to be prime. In other words, it cannot be factored. Its only factors technically are 1 and itself. And our last couple examples here are going to be to solve equations. Again, we're going to be using the zero product property. So I need to factor each one of these first. So for right now, I'm just going to ignore the equals 0 and try to factor this trinomial. So I need two numbers that multiply to 3 times 20, which is 60. And then the same two numbers have to add up to 17. So unfortunately, there are a lot of factor pairs of 60, so I'm going to start listing some of them. And the way I do this is I just start counting. Does 1 go in? 2? Does 3 go in? Does 4? 5? 6? 7, 8, 9, 10. Okay, I think those are all of the factor pairs. This one's a little more straightforward because all I have is pluses in there. So I'm looking for two numbers that add to 17. And the only ones that are going to work here are going to be 5 and 12. So 5 times 12 gives me 60. 5 plus 12 gives me 17. So I'm going to use those two numbers to rewrite 17x. 3x squared plus 5x plus 12x plus 20 equals 0. Now, one question you may be asking yourself is, why did you put the 5x first instead of the 12x? It doesn't really matter. These two are interchangeable. I could have put 12x first, followed by a 5x. It really doesn't matter. Your steps are going to look a little different, but you're going to end up with the same answer in the end. So, putting parentheses around the first two and around the last two. Out of my first set of parentheses, I can take out a greatest common factor of x. And that leaves me with 3x plus 5. Out of my second set of parentheses, I can take out a greatest common factor of 4. And that's going to leave me with 3x plus 5, which looks really nice. So one of my factors is 3x plus 5. The other takes the x and the 4, puts those in parentheses. Now I have my polynomial factored. Now I can use the zero product property, which says that 3x plus 5 equals 0 and x plus 4 equals 0. Solve each one of those for x, subtracting 5 from both sides. 3x equals negative 5, and dividing both sides by 3. X is equal to negative 5/3. And subtracting 4 from each side, x is equal to a negative 4. Okay, and those are my two solutions. And let's take a look at one last example. This one actually has a minus in the middle, so it's going to be a little more complicated than the previous one. So I need two numbers that multiply to 24. In other words, 3 times 8 is 24. And then the same two numbers have to add up to a negative 10. So if numbers don't jump into your head right away, go ahead and make a list of the factor pairs. And I think I am liking 4 and 6 because I know 4 plus 6 is 10, or if I do a negative 4 and a negative 6, that works, as does a negative 4 and a negative 6. They multiply to a positive 24. So I'm going to use the negative 4 and the negative 6 to rewrite the negative 10. So 3x squared minus 4x minus 6x plus 8 equals 0. Parentheses around the first two, parentheses around the last two. Grab that minus in front of the 6 and put a plus up top. Greatest common factor in the first set of parentheses is an x, leaving me with a 3x minus 4. Greatest common factor in the second set of parentheses is a 2, but because it starts with a negative, I'm going to make it a negative 2, which is going to leave me a 3x minus 4. Don't be confused by that negative 4, because remember when I distribute, I'll get that positive 8. So my two factors are 3x minus 4 and x minus 2. Using the zero product property and setting each one to 0, I'll have 3x minus 4 equals 0, x minus 2 equals 0, or 3x equals 4, or x equals 4/3. And adding 2 to both sides, x equals 2. So in this lesson, we learned how to factor a trinomial of the form ax squared plus bx plus c, where a is greater than 1, and then to use the zero product property to solve equations that are of that